Concept of GraphQL fragments. Your GraphQL client application should be using fragments everywhere. The beauty of using GraphQL fragment is if your fragment is used in numerous queries or mutations, it will automatically update. The components associated with those fragments will automatically update if any of the mutation returns an updated fragment. You don't have to manage any update logic or storing that in a cache or storing that in a store and then updating it. Second thing is the GraphQL cache. So if you're using Apollo, it will auto manage caching all the objects and also the fragments in a cache. It will maintain the cache all by itself, cache it, purge it, and update the cache. And all of this is abstracted away from the developer. If you want to access, you can still access it and do optimistic writes and optimistic cache updates on it. The another beauty of using Apollo with GraphQL cache is, let's say you have two queries which are requesting some overlapping data. If the new query is requesting any additional fields, the cache will ensure that the network request will only request the fields which are new in the new query. Apollo will ensure that the network is only requested fields which are not already prefetched in an existing query. This entire concept of GraphQL where you can write custom fields or you can write custom computer fields, the beauty is, although, for example, you might be accustomed to using a application level load balancer, which can do load balancing at the level of application layer, like at the individual request levels, HTTP requests, you can do some sort of load balancing. But if you're using GraphQL, you can actually do load balancing on the field level. What I mean by that is, let's say you add a computer field on your GraphQL schema, and only when that field is resolved, you go and look up your set of services. Only when that field is requested, you go through your load balancer for a service, external service, and you fetch the value for that field. The most important thing here is to notice you have the convenience of not requesting that field. If that field incurs some sort of network overhead or some computational overhead, until and unless the field is requested from the front end in a query, GraphQL will not hit that external services or the computation. Doing something similar in a REST architecture is very difficult. First, you have to ensure that the client is not expecting that field, and only then you have to go and fetch or make that external call. Although another very important thing is the very modular and clean architecture of having computed fields. Although it is not very specific to the GraphQL only, you can still do similar things on the REST. You can have your computer field pointed out to a complete different microservice. But the beauty about using GraphQL is, again, until and unless the field is requested, your external service or your external microservice will not be hit. The next idea is you have the concept of the graph. So this is very specific to GraphQL where GraphQL promotes this concept of expanding the graphs for your API. For example, you can even have cyclic graphs. For example, you have a inbox item which includes a list of chat messages, and every chat message can also have a pointer to your parent inbox. And even if, let's say, you can have chat messages which can have children as messages, for example, for supporting threads, even they can have a support for fetching the inbox which is associated with any of the child chat message, and so on and so forth. Your front end follows this kind of a tree structure of components, and the GraphQL supports and mimics that kind of a pattern where you can have a similar tree or a graph implemented at your API level. So if you are using a GraphQL codegen with your implementation on the front end, you would be able to auto generate a strongly typed request, response, and all the types from the schema itself. One of the problems which happens eventually is it's very difficult to keep track of very specific details of a field on a API. For example, if a field is nullable or it might not be returned, which is undefined, that makes it quite a challenge to keep your types for the API up to date always if you're manually managing the types for your API request and response. But with GraphQL codegen, you can specify your schema, and that will ensure that the types that your front end is using is always up to date. One of the big mistakes I have seen people doing with the GraphQL is on the backend side, they tend to return the objects from their service layer, their existing service layer directory as it is, to the client. My recommendation there is you should never return the object that you're getting even from your service layer directly as it is to your client. Always transform and map it to the kind of data that the client expects. There is a lot of advantage in taking this approach. For example, the business logic and the computation that the client would have eventually done, that can be offloaded to backend, and that can be returned as a computer type. A very simple example here would be, let's say if you have a user object which has a first name and the last name, and the client is always expected to render a full name on the front end. Instead of having a concatenation done on the front end somewhere, you can have a computed field which will say full name. And while doing the transformation, you can have this computed field added in your schema, which will always return the full name for the user. This way, even more complicated business logic that front end usually ends up doing for the store, for the Redux store, or computing some sort of computed fields, all of that can be offloaded to the backend. This enables the creation of a very light and simple clients in which all the business logic is tucked into a strongly typed, well-tested backend service. This approach also ensures that we are never over-delivering things to the front end, which are not at all required. This is great from the security, privacy, and from the perspective of network performance. Again, achieving something similar on a REST kind of an API is somewhat achievable, but again, it won't be very performant in a way that even if you're returning computed fields in your REST API, and until and unless you have to also ensure that, until and unless these fields are requested from the front-end client, you should not do the computation. And one of the last features that I really love about GraphQL is the support for the subscriptions, which means even if you're delivering fragments over a subscription like a WebSocket link, you will still get the automagic and the goodness of using the fragments everywhere in your application, which means once your subscription is updating a certain fragment, the associated components, wherever they might be in your application, they will auto update. That's all for this video. Let me know if you have any questions in the comments below.